Hi everybody, today we're thinking about what the derivative of ln of x is. So if we define g of x to be ln of x, then what would g dash of x be? So we're going to start by giving us a new function, f of x equals e to the power of g of x, which is e to the power of ln of x, which is just x. But then under differentiation of e to the power of g of x, we get e to the power of g of x times g dash of x by the chain rule. And under differentiation of x, we get f dash of x equals 1. So these two things must be equal. E to the power of g of x times g dash of x must just equal 1. And then if we substitute in ln of x, we get e to the ln of x times g dash of x equals 1, which is just x times g dash of x equals 1. But hang on, what that means is that g dash of x must just be 1 on x. And so we get this derivative for ln of x. So if f of x is ln of x, then f dash of x is 1 on x. If we've got a k out the front, that just stays there, giving us k on x. And if we have ln of g of x, well, it's just going to be 1 on g of x times by g dash of x by the chain rule. And so we get g dash of x on g of x, which is simply just the derivative on the original function. And that's very helpful for us to use. So if we start by looking at the example, ln of 4x take 1, well, the derivative will just be the derivative of 4x take 1, which is just 4 on 4x take 1. And so we're done. Here we've got a quotient, so we've got to use the quotient rule. So the derivative of the first by the second function minus the top function by the derivative of the bottom all over the bottom function. And so then we can cancel the x and the x squared to give us 2x ln x take x all over ln x squared. Now with the further examples that you see here, we could just use the chain rule on the inside function, but that's complicated. So why don't we just use our rules that the ln of a product is the sum of the ln's, so we get ln x plus ln e to the negative x. So it's ln x take x, because the ln and the e cancel, so our derivative is just 1 on x take 1. And so we've made it a whole lot easier to differentiate. And we could do the same thing here. The ln of a quotient is the difference of the ln, so it's ln 2x plus 3 take ln of x squared. We can also bring that power of 2 down to give us ln, or take 2 ln x. And now we're ready to differentiate. So it becomes 2 on 2x plus 3 using our model of derivative on original function over take 2 on x. And so that's done for us. Here we could use a rule back the other way. So we've got the difference of ln, so we could write that as a quotient, or ln of a quotient. So ln of x plus 1 squared over x plus 1 cubed. And we could cancel down the squared and the cubed. And so we're going to get ln of 1 on x plus 1. And then we've got another rule that we can write that as negative ln of x plus 1. And so now we're ready to differentiate. So we can write that as negative, stays out the front, and then it's 1 on x plus 1, using the idea of the derivative on the original function. So in every case, when you get a function, make sure or use the rules to simplify it before you actually differentiate. That's very important that you use the rules to simplify before you differentiate.